Hello, I'm Maryam Mottaghi, a third-year PhD student in Mechanical and Materials Engineering at Western University. I work in the PAST lab under the supervision of Dr. Joshua Pierce, and my research focuses on recycling silicon from solar cells to create anodes for lithium-ion batteries using 3D printing with an open-source toolchain. Our reliance on conventional energy sources has contributed to climate change, and a shift toward renewable energy is essential to address the environmental impact. However, each solar panel has a lifespan of 20 to 30 years, which means after this period, a vast amount of waste containing valuable materials and elements ends up in landfills. Valuable materials is silicon, which has already undergone modification and purification in the photovoltaic manufacturing process, which makes it a high-value candidate for recycling. Silicon is a promising alternative to graphite anodes for lithium-ion batteries due to its abundance and its high theoretical specific capacity. Yet recycling the silicon effectively and using it in battery can be challenging. My research addresses the challenges by developing a method to upcycle silicon waste from photovoltaic cells into battery anodes using a stereolithography 3D printing method. To further reduce the manufacturing costs, I have developed and utilized open source equipment, including an open source ball mill, an open source butter roller, and open source 3D printer. Solar cells we have are in wafer shape, and for using in battery, we need to grind them down to micrometer size. Let me show you. Commercial ball mills are expensive, heavy, and consume too much energy. The initial milestone in the project involved the successful fabrication of an open source ball mill. The ball mill can work with AC power and solar power, which makes it portable, and we can use it when AC power is not accessible. It can grind the silicon wafer down to micrometer and nanometer size, and it is cost effective with 87% saving compared to commercial pairs. It's lightweight and it's highly customizable. Next, since we're using SLA 3D printing method, a mixer is required for mixing silicon with liquid polymer resin homogeneously. So the next step was the fabrication of the open source butter roller. The butter roller is cost effective, has the ability to adjust the speed, and is customizable. And also it's able to work at the elevated temperatures. The findings are promising. The fabricated anodes showed a specific capacity of 400 mAh per gram. It maintained 89% capacity retention and achieved over 100% Coulombic efficiency after 200 cycles. This is the 3D printed anode, and this is the commercial graphite. These results not only surpass the performance of conventional graphite-based anodes, but also align perfectly with circular economy principles by repurposing solar waste.